On November 14, 2023, something unprecedented happened. Voyager 1, the legendary spacecraft that had ventured far beyond the solar system, abruptly fell silent. For the first time in its long and storied journey, it transmitted nothing but a meaningless, garbled stream of binary data, leaving scientists and engineers scrambling in disbelief. It seemed that the spacecraft, which had once been humanity's trailblazer into the deep, dark expanse of space, was lost forever. The culprit. A memory failure in its onboard flight data system, FDS, which threatened permanent communication loss. Yet, in the face of what seemed like an insurmountable setback, the dedicated team of scientists and engineers refused to accept defeat. They began crafting an audacious plan, one that would involve reallocating code to different sections of the spacecraft's memory. A highly complex operation was underway, one with incredible risks, given the vast distance between Voyager 1 and Earth. Each signal from Earth took 22.5 hours to reach the spacecraft, and the same amount of time for a response to be sent back. Every attempt felt like a leap into the unknown, with no guarantee of success. Then, just 2 days later, after months of anticipation, an astonishing breakthrough occurred. Voyager 1 re-established contact. This moment marked a triumph not only for the engineers who worked tirelessly to resolve the issue but for humanity's quest to push the boundaries of space exploration. Yet, the real mystery remains: what astonishing discoveries did the Voyagers make at the very edge of the solar system? Why were these findings so different from what scientists had predicted, and what secrets might lie within the mysterious signal Voyager 1 sent back after its eerie silence? The story of Voyager begins long before this dramatic communication loss. In the late 1970s, a rare cosmic event unfolded, a planetary alignment that occurs only once every 175 years. The gas giants, Jupiter, Saturn, Uranus, and Neptune, aligned on one side of the solar system, creating a once-in-a-lifetime opportunity to explore them all in a single mission. This rare alignment would allow a spacecraft to use the gravity of the planets themselves to slingshot through the solar system at unprecedented speeds. NASA seized this once-in-a-lifetime opportunity by launching 2 spacecraft, Voyager 1 and its twin, Voyager 2. Voyager 1, with its faster trajectory, soon overtook Voyager 2, speeding through space at an astonishing 38,000 miles per hour compared to Voyager 2's 34,360 miles per hour. Just 13 days after launch, Voyager 1 captured a historic image of Earth and the Moon, taken from a distance of 7.2 million miles. It was the first time we saw our planet from such a vast distance, a symbol of the beginning of an unprecedented journey. By 1979, both spacecraft had reached Jupiter, revealing groundbreaking discoveries: the faint rings of Jupiter, 3 previously unknown moons, and the first up-close images of its largest moons. Voyager 1 confirmed that Ganymede, not Titan, was the largest moon in the solar system, and it revealed the smooth, cracked ice surface of Europa, sparking theories of a hidden subsurface ocean beneath the ice. But Jupiter was only the beginning. Using the gravity of the gas giants to accelerate further, Voyager 1 and Voyager 2 moved on to Saturn, arriving in 1980 and 1981. Here, the 2 probes transformed our understanding of the gas giant, discovering its intricate ring system and 4 new moons. One of these moons, Mimas, with its massive Herschel crater, was eerily reminiscent of the Death Star from Star Wars. However, it was Titan, Saturn's largest moon, that remained a tantalizing mystery. Its thick atmosphere blocked out visible light, but data suggested a temperature close to the triple point of methane, an intriguing condition where methane could behave like water does on Earth. While Voyager 1 explored Saturn, its twin Voyager 2 continued on its planetary odyssey, reaching Uranus in 1986 and Neptune in 1989. Voyager 2's flyby of Uranus provided surprising revelations. Unlike Jupiter and Saturn, which are mostly made up of hydrogen and helium, Uranus had a thin outer layer of these gases, with a massive ocean of water, ammonia, methane, and hydrogen sulfide beneath, surrounding a dense core of rock and ice. This discovery led scientists to reclassify Uranus and Neptune as ice giants. Interestingly, Uranus was found to be the coldest planet in the solar system, even colder than Neptune. Voyager 2's final stop was Neptune. In August 1989, it captured the first ever detailed images of the planet, completing its grand tour of the solar system. Neptune appeared strikingly blue, though later analysis revealed its true color was closer to teal. At this point, Voyager 2 had completed its mission to explore all the outer planets, but Voyager 1 had a different fate ahead of it. After its flyby of Saturn, much of Voyager 1's scientific instruments were powered down, but it still had one more historic moment to capture. On February 14, 1990, Voyager 1 turned its cameras back toward Earth and snapped a photograph from an astonishing 3.72 billion miles away. The image, famously known as the pale blue dot, showed Earth as a tiny speck, just 0.12 pixels in size, set against the vastness of space. It became one of the most iconic images in human history, and it marked the final time Voyager 1's cameras would ever operate. After that, both Voyager spacecraft entered a long, quiet phase. For over 15 years, they transmitted little data back to Earth, but then something extraordinary happened in August 2012. Voyager 1 recorded a dramatic drop in solar particles and a surge in cosmic radiation. The spacecraft had officially crossed into interstellar space, becoming the first human-made object to do so. Voyager 2 followed in 2018, marking the end of the grand tour of the outer planets, but the twin explorers were now moving on separate paths into the unknown. The heliosphere, the protective bubble surrounding our solar system, extends about 11 billion miles from the Sun. It is created by the solar wind, a constant stream of charged particles emitted by the Sun. The boundary where this solar wind ends and interstellar space begins is called the heliopause. Both Voyager 1 and Voyager 2 crossed this boundary, sending back groundbreaking data. The discovery that the solar wind didn't just fade but encountered a sharp boundary was revolutionary. This was not the gradual transition scientists had predicted but a clear-cut boundary separating the solar system from interstellar space. Voyager 1, currently traveling at approximately 3.5 astronomical units per year, an astronomical unit is the average distance between Earth and the Sun, about 93 million miles, is heading toward the Lyra constellation. In about 38,200 years, it will pass within 1.7 light-years of a star known as AC plus 7938, located in the constellation Ursa Minor. Meanwhile, Voyager 2, moving at 3.1 astronomical units per year, is expected to approach the star Ross 248 in the Andromeda constellation in about 40,000 years. Though the Voyagers have left the heliosphere, they have not yet fully exited the solar system. The Sun's gravitational influence extends much further, potentially reaching the Oort cloud, a vast region believed to be home to comets. If the Voyagers continue on their current trajectories, Voyager 1 will take approximately 300 years to reach the inner edge of the Oort cloud and possibly 30,000 years to traverse it, marking the true end of its journey within our solar system. Throughout their journey, the Voyagers have carried with them the Golden Records, a pair of gold-plated copper discs inscribed with photographs, greetings in 55 languages, sounds of Earth, human voices, and music. These records were designed as a message to any extraterrestrial civilizations that might one day find the spacecraft. Whether or not they are ever discovered, the Voyagers will drift endlessly through the cold void of interstellar space, a testament to humanity's curiosity, ambition, and desire to explore. The Voyagers are not just machines, they are symbols of our unyielding quest to understand the universe, to reach beyond our planet, and to explore the unknown. With their scientific instruments still transmitting data back to Earth, the Voyagers continue to offer invaluable insights into cosmic radiation, galactic winds, and the interactions between our solar system and the broader galaxy.